In this video, I'm going to start here and I'm going to calculate the uncertainty for a couple of these guys. Okay, so let's divide this space. There we go. Let's do one of the uncertainties. Let's find the uncertainty of this guy here. Okay, so this is 8, and we're going to figure out the fastest that could have been, and we're going to figure out the slowest that could have been. Okay, the way we do this is we look at the distance, right? Here's our distance. And we figure out what the boundaries of that is. So for example, we thought it was 30, right? Okay, but it could have been as big as 31 and as small as 29. I got this by saying plus 1, and I got this by saying minus 1. Okay, now for this time right here, for that guy right there, okay, the time was 3.75. That's what we thought it was, right? Now this uncertainty of time, we figured something out in your class, but you can just use 0.2. If you're making up the lab, let's just use 0.2. That's easy. Okay, so let's say the time is plus or minus 0.2. That's the uncertainty. We're sure that you didn't make a mistake bigger than 0.2 of a second, which is really pretty big margin of error. Okay, now that means 3.75 could have been as big as 3.95. This is plus 0.2, right? Okay, is what we're doing there, right? And then it could have been as small as well, 3.75 minus 0.2 is 3.55, right? That's the smallest it could be. That's what we think it is. That's the biggest it could be. These are the boundaries of our uncertainty, right? So now we're set. We can figure out the max. Okay, the max is equal to the biggest numerator, because we're going to divide one of these by one of these, right? Divided by the smallest possible denominator. This is, I can't really explain that. You want to make your numerator big and your denominator small. Aren't you glad I'm not your math teacher? I'm sure there's some good mathematical reason, right? Numerator big, denominator small. So we divide those guys, right? Okay, so 31, I go 31 divided by 3.55. 8.73. Okay, so this thing could have been as big as 8.73 meters per second. Okay, let's figure out the minimum it could be. Okay, for minimum we use the smallest numerator. Okay, we're going to divide one of these by one of these. We'll use the smallest numerator, divide that by the biggest denominator. Because of math, that gives us the smallest value. So 29. This is called brute force uncertainty. Okay, 29 divided by 3.95. So 29 divided by 3.95. Did I do that right? I did. Okay, here we go. Enter. 7.34. And that's meters per second, okay? So this is our min, this is our max, okay? For this particular one right here. And I didn't convert them into miles per hour. You could do that if you're really curious. Let me do another example. Let's do this guy here, okay? So for this guy, yeah, it really wants to go that way. There we go. I love drawing those straight lines. Okay, so let's look at this guy, okay? For 4.15, for this time right here, okay, again the distance is still 30. It's still true that it could have been as big as 31 and as small as 29. This is 30 plus 1, right? This is 30 minus 1. And then 4.15 is the time we think it is, right? Okay, but the time is plus or minus 0.2. This is, we just guessed that the uncertainty is about 0.2 of a second, okay? So the biggest that could be is 4.15 plus 0.2, right? You don't need to write that down. Let's see, that would be 4.35, right? And the smallest that could be is, oh, this is higher math, 3.95. That being 4.15 minus 0.2, okay? Now, remember that velocity is distance over time. So to get the max, we're going to divide one of those by one of those. So to get the max, you divide the biggest numerator, that's this guy, by the smallest denominator. Okay, So the max is going to equal the biggest numerator by the smallest denominator. So 31 divided by 3.95. Okay, so that equals 31 divided by 3.95. That's 7.8, I'll say 85, 7.85. I'm sort of rounding there. Right, so we thought it was 7.23, but the biggest it could be is 7.85. Now we'll figure out the smallest it could be, right, and that's meters per second. The smallest it could be, our minimum, okay, is the smallest numerator. It's one of these guys divided by one of these guys, right? So we'll make this guy small, right, and we'll make this guy big. We use the biggest denominator, okay? So 29 divided by 4.35. Okay, so 29 divided by 4.35. No, my gosh. 6.6. I'd say 6.7. There we go. Meters per second. There we go. Okay, so this is our maximum. That's as big as that could be. This guy also could be as small as 6.67. Okay, meters per second. Now, here's what I want you to do. I want you for at least two of these, at least two of them, I want you to show me at least show me this much. I need to see your calculations in that, okay? I want to see at least that for two of them, okay? You don't need to do this explainy thing here, right? You don't have to do all the things like that. I do want to see this. I want to see that you're changing, making the numerator bigger, the denominator smaller, making the numerator smaller, denominator bigger, okay? I've got to see that or I won't know that you know how to do this. Okay, so that is brute force uncertainty. So for two of them, show me, right? And for the rest of them, just calculate it. You can just calculate it flat out, right? You could just maybe make another column, a couple columns, max and min, max and min, max and min, or something like that. Okay? Yeah, that's uncertainty. It's complicated, but you guys are so smart. I know you can do it.